Hidden dangers of leakage current. Welcome to this presentation on the hidden dangers of leakage current. In this session, we'll explore what leakage current is, why it happens, and how even small unnoticed currents can lead to serious electrical and safety problems. Introduction. Leakage current refers to the small amount of unintended electric current that escapes through a device's insulation or grounding path. It's often caused by aging components, moisture, or wiring faults. While usually tiny, this current can build up or leak to exposed metal parts, posing significant risks to users and equipment. Causes of leakage current. There are several causes behind leakage current. Over time, insulation materials can degrade or absorb moisture, creating a conductive path. Dust or dirt on circuit boards can also lead to unintended conduction. Improper grounding or damaged electronic components further increase the likelihood of leakage. Hidden dangers. Leakage current might not trigger alarms, but its effects can be dangerous. It can cause electric shocks, create heat buildup leading to fires, or damage sensitive electronics. Over time, it also weakens insulation resistance, making future failures more likely. Impact on humans. Even small leakage currents can have severe effects on the human body. Currents as low as 1 milliamp can be felt, while 10 milliamps can cause pain or involuntary muscle movement. At 30 milliamps, breathing may become difficult, and above 100 milliamps, the result can be fatal electrocution. That's why understanding and controlling leakage is critical for safety. Impact on equipment. For electrical and electronic equipment, leakage current can mean reduced reliability or even total failure. Sensitive systems, such as medical or industrial control devices, may malfunction or lose data. Persistent leakage can also lead to corrosion of metallic parts and premature aging of components. Detection methods. To detect leakage current, engineers use tools like insulation resistance testers, commonly known as megas, or specialized leakage current clamp meters. Routine inspections and preventive maintenance help identify early warning signs before the situation becomes. Prevention and safety measures. Prevention starts with good design and regular maintenance. Always use residual current devices or earth leakage circuit breakers for protection. Keep electrical systems dry and clean, perform insulation tests regularly, and ensure proper grounding and cable quality to reduce leakage paths. Real-life case example. In one real-world example, a hospital experienced intermittent malfunction of life support equipment due to unnoticed leakage current. Moisture and degraded insulation caused current to flow through the system chassis, leading to data loss and potential shock risk. Timely detection and improved grounding solved the issue. Conclusion. In conclusion, leakage current is often invisible but never harmless. It can threaten both human safety and equipment reliability. Regular testing, proper grounding, and the use of protective devices are essential to prevent these hidden dangers from turning into costly or fatal incidents.